Next, we are going to see about approximation algorithms for NP-hard problems. Here we are going to see about accuracy ratio. The accuracy ratio is nothing but accuracy approximation to the actual optimal solution. That is, we are going to find how much your approximation matches with the actual optimal solution. The actual optimal solution can be any one of these methods which we followed. It can be a knapsack method, brute force method, or any of the method what we have followed previously. We have seen brute force method, divide and conquer method, dynamic program methods. Many methods have been seen. The actual can be of anything, but accuracy will be given. Here the formula for calculating the accuracy ratio is f of SA divided by f of S star. S star is the exact solution for the problem. That can be done by any methods. SA is the accuracy, measure of accuracy. Here performance ratio is calculated. The best upper bound on the accuracy ratio taken over all instances of the problem. That is, accuracy ratio calculate பண்ணி வச்சிருப்போம். அதில் best upper bound எதுவோ that will be considered the best performance ratio. இருக்கக்கூடிய எல்லாத்துலேயும் எல்லா இன்புட்லேயும் accuracy ratio calculate பண்ணி இருக்கும்போது அந்த accuracy ratioவில் பெஸ்ட் எது, accuracy ratioக்கான upper bound best எதுவோ that will be considered the performance ratio. Approximation algorithms for NP-hard problems. Here C approximation algorithm is represented. The C approximation algorithm is nothing but f of SA is less than f of S star, where we say that is what we C is nothing but the performance ratio. It is at most C. C is the performance ratio is given as C. Here we know that what is the meaning of SA and what is the meaning of S star. So C approximation ratio is considered such that SA is the approximate solution. Approximate solution will be less than the solution S star. With C is the performance ratio. Now this is the approximation algorithm for traveling salesman problem. There are two approximation algorithms. One is nearest neighbor algorithm and another is twice around the tree algorithm. The procedure for nearest neighbor algorithm is you have to start from any arbitrary city, go to the nearest city, repeating till all the nodes are visited, and return to the starting city. This will be more similar to the traveling salesman problem what we have seen. We will see with the help of an example. Here these are the various nodes with the weights. All possible tools are given: A to B, B to D, D to C, C to A, with the length of 12. And all possible combinations are found satisfying the rules of traveling salesman problem. The rules of traveling salesman problem is no node to be visited twice and constant of traveling salesman problem, all the nodes should be visited. Constant is all the nodes to be visited and the starting node should be the ending node. Here we are unable to follow with all the rules. Here we have seen all the possible combinations. Because this is an approximate calculation, we have seen all possible combinations of visiting. So when we have seen all possible combinations, in that all possible combination we have to find the combination which satisfies the rules of traveling salesman problem, and that should have minimum length. Here A to B, B to D, D to C and C to A satisfy all the rules of the traveling salesman problem with the minimum length of 12. Here this also satisfies the constraints of traveling salesman problem. This constraint also satisfies the conditions of traveling salesman problem. This also satisfies the conditions of traveling salesman problem. But Among these four values, we get 12, 14, 18, 18. The minimum will be considered. So this will be the minimum that is considered. And the optimal will be A, B, D, C, A. Because this is the minimal. And nearest neighbor weights are going to calculate this. We have selected the optimal A, B, D, C, A with the length of 12. Now the nearest neighbor weights are calculated. And nearest neighbor calculation has A to B is 2 and B to C is 3 and C to D is 2 and D to A is 7. There is no concept of optimal solution. Exhaustive searching mechanism is not used. Nearest neighbor is considered and that is taken. Result is 14. So here accuracy ratio how we are going to calculate is we are going to calculate the nearest neighbor value what we get divided with the optimal solution achieved by exhaustive search. So 14 by 12 gives you 1.16, which means that 2 SA is 16% longer than the optimal 2. SA is 16% longer. That is 14 is the value. Here we got 12. 16% longer than the optimal 2. Twice the horn tree algorithm. Here we are going to construct a minimum spanning tree as we have seen in the previous unit. We are going to construct a minimum spanning tree and start the arbitrary tree and walk around the tree. Eliminate the duplicates from the generator node. So minimum spanning tree is constructed. We have seen in Freud's algorithm. We have seen in Washer's algorithm. We have seen how to construct a minimum spanning tree. And after constructing the minimum spanning tree, we had to walk around the tree and record the nodes visited. So that meaning is there should not be any duplicates in the node with this generator. We have to check based upon the node without any duplications. Next is approximation algorithm for knapsack problem. There are two methods. One is greedy algorithm and other is approximation schemes. In greedy algorithm, we go for discrete knapsack problem and continuous knapsack problem. In discrete knapsack problem, we are going to compute value by weight. And same procedure as we do in knapsack problem, we are going to find value by weight. And after finding the value by weight, we are going to sort the items in non-decreasing order. And we have to repeat checking that நம்ம எந்த ஐட்டம் தேவையோ அந்த வெயிட் வந்து knapsack ஃபிட் ஆன யூஸ் பண்ண போகிறோம். ஃபிட் ஆகலைன்னா டிஸ்கார்ட் பண்ணிட்டு அடுத்த ஐட்டம் ப்ராசஸ் பண்ண போகிறோம். This is discrete knapsack problem. Next is continuous knapsack problem. Next is compute value by weight for all items, sort the items in non-decreasing order. Everything is same and if current item fits, use பண்ண போகிறோம். If it is not fitting, in the previous step what we did is we discard and we go for the adding the next item. Here, if it is not fitting, we have to take its largest fraction to fill the knapsack. The difference is there, if it is not fitting, we will discarding and we will taking the next item. Here, if it is not fitting, we are going to take the largest fraction to fill the knapsack.